Hello, YouTuberverse. StarTalk coming up next. Cosmic Queries, the edge of the known universe. This is StarTalk. I'm your host, Neil deGrasse Tyson, your personal astrophysicist. Today, we're doing Cosmic Queries. Topic, the edge of spacetime, the edge of the universe. Chuck.
Hey, Neil.
You going to join me there?
I am.
But we can't do it alone.
And that shirt.
He trolled us.
You know, whether you're watching or listening, that I wear cosmically colorful clothing.
Yes.
But my shirt I'm wearing today is particularly cosmically colorful.
Yes.
It's in your face. It's smack down. It's
well, we're going to have to take a picture of it, and you're going to have to go to YouTube. We'll take a picture of it, and you have to see this shirt. You have to.
Yeah.
Seriously.
It's some pretty lovely celestial bodies going on there.
We have Janna Levin to help us.
Yeah.
Janna,
Always glad to
Professor
be
of Physics,
here.
Barnard College, Columbia University. Welcome back.
I love being here.
We needed you
Great.
for this topic. Because my knowledge of cosmology is little, and yours is big.
not as big
As the universe itself. Okay. All right. So anytime we do a Cosmic Queries,
right.
we bring her in.
I love it.
We bring the big guns.
This is, and Janna is the big guns, man.
Right.
Yeah,
Right.
good stuff.
So what do you have?
So we got Cosmic Queries as we glean from all over the internet. And of course, we always start with the Patreon patron because
Just a quick sec. So your book, Black Hole Blues.
Yeah.
That's still out there.
Yeah, it's still out there.
Okay, Chuck, we got to do it.
Black Hole Blues.
I've got to learn a harmony to that. I can be like, over here.
There's got to be a way when someone picks up the book, it says,
I was Black Hole Blues.
guaranteed more sales.
What if you just, every time you walk past it on the shelf?
No, you just heard it.
Yeah, that'd be so cool. Yeah.
It's great.
We got to
With
put
a
it on
little
your
riff,
shelf
with
right
a little
here.
riff behind it. You know? Black Hole Blues. No.
So that was about the discovery of gravitational waves
Yeah, so
moving through the universe.
yeah, exactly. So right before that succeeded, in the 50 years it took them
Before
to
we
succeed.
successfully measured it.
Yeah, Ray Weiss, who's one of the original architects, just was shaking his head and saying, if we don't detect black holes, this thing is a failure. So like the whole title was just kind of like, it's the Black Hole Blues.
But then he detected it, so
Yeah.
it's got a new title.
Yeah, the new
Black
title is
Hole
called
Jitterbug.
Nobel Prize winner.
The Black Hole Nobel Prize.
The Nobel Prize jig.
He's sad all the way to the bank on that one. Yeah.
Nice.
All right, so good to hear it's still out there.
Yes, thank you for that.
Let's start off though with the Patreon patron. This is Chris Hampton, who supports us on Patreon, who wants to know this. Could it be that the universe that we are in is actually finite? However, the universal structure is infinite via size and relativity, meaning the universal structure gets infinitely smaller and vice versa, kind of like infinitely dividing in half. I imagine it would look something like a very complex fractal.
Well, he's going a lot of places.
Wow.
All right, Jen, take that however you want.
I'm going to write.
And I have a question for Chris first. Is it sativa or indica? Sativa? Indica. Okay.
Which is the one that he would have fallen asleep before making it to the end of the tweet?
Not the sativa.
I think that, I don't know.
Is that the end?
I maybe that's the indica.
Okay, well,
I don't
we
know.
just all revealed our.
Yeah. When I actually used that substance, it was called weed. They didn't put any other name on it. Like if you went to
Easy to pronounce and remember.
and that was it, right? If you went to your dealer and you went, so now is this sativa or indica? He'd be like, man, what's wrong with you? Smoke it. Get the hell out of my house. Go smoke that and get out.
Perfect.
Anyway, so you want to take a shot at this?
I'm into this.
Okay.
So, my first book is about whether or not the universe is infinite or finite. It's a question we don't know the answer
And the title of that book?
yet. How the universe got its spots.
I remember that, yeah.
So how the universe got its spots is about, could we tell the shape and size of the universe by looking at the hot and cold spots in the Big Bang and the light left over from the Big Bang? But the question, let's just take it really theoretically. We absolutely do not know that the universe is infinite. And it may well be that it's finite the way the Earth is finite. That, we leave New York City, we travel in a straight line. Maybe we'd have to swim a little, get on a boat, but you travel in a straight line, you're going to come back to New York City again. Right. And so it could be that
But you can travel forever.
I was going to say, it's infinite in what you can travel and where you can travel.
It's infinite and you don't get to an edge.
Right.
You never get to an edge, which is beautiful. So exactly the same thing with the universe. You're not going to sail off the edge of the Earth, right?
Mm-hmm.
Like, Spanish explorers waved goodbye and wondered, right, if they'd just go off the side. But no, we know that's not what happens. And so similarly, we could leave the Milky Way galaxy. We could watch it recede behind us. We could travel in as straight a line as possible and find ourselves coming back to the Milky Way again. Wow. And it's so Planet of the Apes, right? It's like,
damn you! You finally did it! Damn you all to hell! Oh, that'd be
so
great.
So my interpretation of that was that they went all the way around. Yeah. Mm-hmm. And so the interesting thing is that also means that if you look at distant galaxies, the light is also traveling all the way around the universe. So it could be that some of those distant galaxies are the Milky Way, and we're seeing the light from the Milky Way wrap all the way around and come back to us. So we'd be seeing the Milky Way in the past. Wow. So it would be hard to know. Like maybe we'd see an active black hole quasar with jets flying out in the early phases of the Milky Way, and we'd think, oh, that's just a different galaxy.
Oh.
Wow.
Yeah. So
because galaxies, young galaxies look very different from mature galaxies.
Right.
And we used to think that there were different kinds of objects in the outer universe, like quasars. Why are they all distant? How come there's not a quasar right next door with these monstrous nuclear emissions? And we had to like figure out that it's likely just younger galaxies, and maybe we used to look like a quasar and we don't anymore.
Right. So even a distant galaxy looking back at us is seeing us in the past, given the light travel time. So we could still look like a quasar to a distant galaxy. Wow. Like I have this huge active galactic nucleus.
Because they're not seeing us as we are now.
No, they're not.
They're seeing us as we were.
Billions of years ago. Yeah.
Oh my God.
So that's the beauty. We get to see
need
the
some of that
past.
sativa right now. Wow.
Well, and then it gets more because there are reasons that people start to suspect that there are extra spatial dimensions and that they are not only finite, but really technically really small. Like that journey to go all the way around them is something that would happen incredibly quickly. And it's too small for us to like literally stick our hands in that direction in some sense. So we're looking everywhere. Those extra dimensions are everywhere, but we can't actually notice them.
Wow.
And so
What does
then
it mean for a dimension to be smaller than another dimension? What does that even mean?
So think of like a straw is a good example where it's a two-dimensional surface.
You know
but
what the
one
first straws were made of?
I'm going to go with flax.
No. Yeah, straw. Yeah.
Thank you. Thank you for getting that. I knew I could make that joke to him. I know it. Oh, God. All right, go ahead.
The only reason it's because flax and hair.
Oh, yeah?
Yeah, that's the only reason
color.
why I would
Flax-
have the
flax and-
connection between flax and straw.
Yeah.
So a straw is small in one direction on the surface, right? If you think there's a direction in which it's totally wrapped up and small. And then there's a long direction.
So straws are mostly long.
They're mostly long. And you could glue the top end to the bottom of a straw to make that long direction also finite. So then you travel around the world. It could be really big. It could be, a mile around, but still be connected. But it's only a few millimeters around in this direction.
In this other dimension.
So literally the length of traveling before you come back to where you started is smaller.
So most of how you use a straw does not access that other dimension. It's really the length, because you're trying to get the liquid from here to here.
Yeah.
And so most of you're using the long dimension of the straw.
So then the question we start to ask is, what if the universe is a kind of space-time origami when it's created in the Big Bang, that all the dimensions are wrapped up in maybe in very complicated ways, like the dimension of the straw being wrapped up, but one dimension just gets very, very big, or in our case, three very, very big. We have three big dimensions. We have time, which is a fourth. So there's up, down, north, south, east, west. That's it. You specify those things and you definitely know where you are in space. You specify time and we can actually meet. Right. Here we are. But those extra directions just maybe didn't ever expand. And so one of the things even that I'll work on and string theorists will work on people is, why would only three dimensions get large if those other dimensions exist?
Interesting.
Mm-hmm. So it could be that, we'll understand the large connectedness, finite nature of space by looking in like really high energy, accelerator experiments. Because people have asked at the Large Hadron Collider, could you perceive these extra dimensions if they
Okay. Wow, that I got to tell you,
Okay,
Chris,
we're done with the show.
Chris, that's okay. And people will
an entire show's
we'll be
worth
back
of-
next week. We're just going to let you think about that.
It's a week's worth of mind blowing.
That is
a big start.
That was a big
to
start.
Cosmic Queries.
Wow, man, that's a fascinating stuff. Just fascinating.
Next show.
Okay, so let's move on to Paul Love, who says, given that,
Is that because you can pronounce his name? That's why we're going to him
let me
next?
tell you something. As a matter of fact, I think I'm just going to call everybody Paul Love.
That's a beautiful name.
Exactly. Paul says this, given that our universe expanded from a single point and is expanding in all directions, how does that not define the shape of the universe as spherical? How could something flat or saddle shape come out of that?
So there.
Wow. Right.
Take that, Jen.
Well, it is true. If there is an explosion in space, it tends to have a kind of spherical cloud left over as debris. So when a star explodes, we will see often nebula, and they're like often spherical-ish.
Hey, beautiful too. Beautiful nebula.
Very beautiful. And, sometimes they plow into stuff and that changes the shape. But basically, then you can point inside this debris, you point to where the center of the explosion was. Okay. So that's not how it works for the Big Bang. So for the Big Bang, you cannot imagine that the space exists first and that you're exploding into the space.
Right.
It is actually a creation of the space itself. Right. So everywhere in the universe was once at the center of the explosion.
Exactly.
There is no plowing out. It's as though, and you can think of it any shape you want. Make some crazy, people like the balloon analogy. So now make some crazy balloon, twisted up crazy thing. And,
a poodle.
A poodle.
Oh, nice.
And a balloon poodle universe. And the whole thing stretches. And the whole thing was once a point. So every single point on that surface. And people get
it's
tripped
part
out.
of that fabric, if you want to call it.
Yeah.
So the center is everywhere.
Yeah,
the center is everywhere. We are at the center of the Big Bang, as is every other point in space.
Finally,
the center of the Big Bang.
But can I say that differently? Will you allow me to say it differently?
Please.
Can I say there is a center? The only way you can access it is to go back in time to the beginning of time.
Well, you could say.
Ooh, okay.
You
Oh
could
man,
say-
talk about dimensions.
So you can access the center of all of this only at one point in this coordinate system,
exactly.
and it's at t equals 0.
I would say.
And it's there. If timeline is just always there, there's the center.
Yeah, if we're going to be really, split space up in very fine-grained terms, this point was at the center back at t equals 0, and this point was at the center back at t equals 0. They just were all closer
together, right?
So the whole.
So it's just the collapse of those points at t equals 0.
Yeah.
Gotcha.
Yeah.
But I like what you said, though, which I think is what people have to really think. Is the space itself was created.
Yes.
Right.
At the the millisecond, microsecond, whatever, nanosecond.
A bajillionth of a second.
Bajillionth of a second.
Yeah.
That's an official fraction, isn't
Right,
it?
right.
Bajillionth.
The bajillionth of a second afterwards. That space was created then along with everything else.
I think that's like 10 to the minus 43 seconds.
Yeah, that's
which
right.
would be a trillion,
The Planck-
trillion,
the Planck-
trillion.
There you go. So, right then. So if you think of it that way, because what you're thinking about is these distances between the stuff that we see.
Yeah.
And we think they're empty, but they came from that thing.
Yeah, from the Big Bang.
From the Big Bang.
Yeah. So
God.
a reason why people get tripped up.
Okay, Chuck just blew a gasket.
I know, man. It's so crazy.
Chuck, we just lost Chuck.
I love it.
I would love if there was an actual steam effect.
Out of the ears.
Yeah.
Wow. So wow. Go ahead.
So
Yeah, go ahead.
here's where people get tripped up with the balloon analogy because it's flawed, as are all analogies, is that a lot of people immediately want to point to the center of the balloon, the empty space inside. But you got to give up on that. All that exists is the skin of the balloon. That is all that exists.
I'm okay with the center of the balloon because that's where the balloon was at t equals 0.
Right. So you could think of it, good. I can only consider the center of the balloon as snapshots, like movie frames.
Right.
So it once was there, and then it was a movie frame over here. And then it was
But the center of that same balloon is still now at the outer reaches of that balloon because it came from the center of the balloon.
Right. So imagine you painted dots all over the little infinitesimally small balloon, but they were glued to, there's stains on the skin of the balloon. The dots themselves don't move. And then you push all that down. So all the dots are together and then you pull them apart. In some sense, those are the galaxies that came later. The galaxies aren't moving.
Right.
The stain on the balloon doesn't move. It's the skin, the stretching between the spots. So in fact, nothing piles up the way it does when a supernova explodes. Everything actually just gets more and more diffuse as the universe expands.
Holy crap, man.
Chuck blew a gasket.
I
don't know.
man,
Chuck would have to go on the
Some
heel.
good stuff.
This stuff is
It's some good stuff.
all right,
All right, next question.
Wild, man. All right, that was great. Thanks, Paul. All right, here we go. Let's go to Brendan Rico Suave. You just scroll with me, Brendan. Okay. Brendan wants to know this. I've recently heard of a new study that states the universe is thought to be in the shape of a loop. Whereas previously it was thought to be flat, but in the explanation given, the nature of the loop shape states that it travels far enough in one direction that you'll end up back where you started, which is what we talked about earlier. My question is, wouldn't this happen regardless of actual shapes of the universe? So his point is like, no matter what you shape it, if would that happen?
Yeah. And I think that you can say.
I think that we have to take a break.
Oh. Wow.
I should have seen that at the corner of my eye.
When we come back, Janna Levin is going to tell us, do we live in a loop universe or not on StarTalk? We're back. Cosmic Queries, StarTalk. Chuck Nice, my co-host.
Thank you.
All right. Janna Levin, friend, colleague up at Barnard in Columbia, doing that physics thing. Cosmology.
Someone's got to do it.
Somebody's got to blow people's cosmological minds. And so tell us, as the question had asked, would the universe loop back on itself no matter its shape?
So not necessarily.
How do you know what shape the universe is in the first place?
Yeah, it's really, we don't ultimately know the shape. We know that we can see the distance light has been able to travel since the Big Bang because we can't see anything faster than the limit of the speed of light travel time. And we know that the universe is expanding. So that's actually 92 billion light years across that's what we call the observable universe. Now, it's possible that it's not 92 billion light years across, that even within that range that the universe has folded back onto itself in some way, and we're actually seeing repeats of things. We're starting to see, it's kind of like a Hall of Mirrors thing. We're starting to see the light multiple times.
How'd you know?
Yeah, I was going to say,
how do you figure that out? It is very, very hard to figure out. So there have been extremely clever ideas, and most of them
If I get my
rely...
telescope and look out and I see Chuck waving at me.
Yeah, right, exactly. Right, when he was a little baby. Yeah.
You hear the one about the... Right, okay.
So it's true, we're looking at ourselves in the past, which is very hard to distinguish. For instance, if we're looking at galaxies, that's very hard to do. But there are patterns in the hot and cold spots left over from the Big Bang if it fits into a specific shape. So imagine something just totally platonically beautiful and crazy, that the universe is like a dodecahedron, all of whose faces are glued together. So it's a crazy origami. That thing is, I mean, there has so many loops and
So the
it's
20-sided
yeah, that is
triangles.
right.
20
And that
sides.
is conceivable kind of what we call topology or connectedness of the space. It would actually start to imprint that the patterns of the dodecahedron in the light left over from the Big Bang. So if you imagine there's tiny little hot and cold spots that you would start to see in the distribution of the hot and cold spots. That shape would be reflected in a very subtle way.
Really?
Yeah. So
Wow.
the reason
You don't mean reflected literally. You mean manifested.
manifested.
Right? Yes.
So how the leopard got its spots is actually a very similar mathematical problem because you're asking about enzymes being high or low in the developing embryo. And it turns out that the shape and the size of the animal, and like whether it's tubular or when those spots are hitting it, that it will determine what kind of spots the animal gets.
In an actual leopard.
In an actual
wild.
leopard, zebra, stripes, like these things are things you can predict by solving for the mathematics of things that are above a certain threshold or below a certain threshold, that pattern of stripes or spots will reflect the geometry
And
of
the
the
Black
animal.
Panther is a leopard. You knew that.
Yes, I did know that.
And the Black Panther has spots.
No, that
On
I
its
didn't
skin?
know.
It has spots.
On
And
its skin.
If you look very carefully, you can see the spots.
Oh, wow.
Yeah.
Amazing. Well, so how the universe got its spots is a similar mathematical problem. We're solving for hot and cold spots in a particular geometry when the universe was like a developing embryo, basically. And this goes back to Alan Turing, who solved some of these problems for the animal.
But like a Black Panther, does the universe care about injustices to the black man?
Apparently not, Jack. I mean, if this is any evidence, if this planet
Or
is
Chuck.
any evidence.
Just to bring that into modern reference.
Right.
Or does the universe have vibranium?
There you go.
I'm just saying. Yes.
Well, you know, we can hope that we're the bad example and that elsewhere in the universe there are better examples.
Nice. Well said. Well said.
All right, Chuck, what else you got?
All right, here we go. This is Tim Braid, who wants to know this. A very recent study in the Astrophysical Journal found that galaxies may be rotating in sync with other galaxies millions of light years away. Galaxies separated by 6 megaparsecs were found directly interacting with each other. What is your opinion on this? First of all, is that empirical? The fact that these galaxies were actually interacting with one another?
I think that study is probably still controversial and probably still requires
I mean,
other.
probably wrong. I'll be your translator.
I can't
That's an
say.
interesting study. Probably wrong.
Yeah.
It's controversial. Probably wrong.
I mean, these things can happen, but it just sounds not that likely. And so there will be a lot of people doing observations in different wavebands with different perspectives to try to break any possibility that it's a quirk of this particular observation. But 6 megaparsecs, that's pretty far away.
Yeah.
And so you would think that you would be dominated there by the expansion of the universe and not interactions. We definitely interact with other galaxies. That's not a big surprise. So
the nearby
Andromeda,
ones, yeah.
Andromeda's, we're fine. We're going to collide with Andromeda. That's a happy future. Like, imagine when Andromeda gets much closer, how cool the night sky is going to be.
Hey,
like, it's going to be like right there. You're going to like see a whole
Actually,
galaxy.
it won't be as cool as you think. I'll tell you at the end of your answer, though. It's not going to be as cool as you think.
Because is it coming in edge on?
No.
You can tell me
I'll
it's
tell you
not
why in a
face
minute.
on?
It's a disturbing reason why it's not going to be cool.
So now, speaking of edge on, now I'm sorry, because I'm a little all over the place,
Yeah.
but I got to get this in before we move on.
Yeah.
So speaking of edge on, so if you're looking at something edge on, how do we flip it to get the imagery to know that we were looking at the disk from the edge?
So we do that with our own Milky Way. We're in the Milky Way, so we're seeing the rest of the galaxy edge on.
Right.
We've never seen the Milky Way as
From
human beings from
above.
above, but we have these beautiful constructions because we just map things as accurately as we understand where they are also in space.
Okay.
So we build an atlas of it, basically. You build a numerical model based on all of your observations of the Milky Way, the gas, the dust, the stars, everything, where the spirals are, where the gaps are, and then you just allow yourself to move in that digital world and look down from above. But it's an experiment.
So it's a modern version of map making. Because
Right.
you make a map in
Map
3
making.
dimensions.
Exactly.
Yeah.
Once you have a map, you can go anywhere you want. In a
Right.
3-dimensional map, you can go anywhere.
Yeah, you
and
can-
plus, we see all the gas and we're kind of flattened in the sky. And there are other galaxies out there that are flattened, and we can see them at all. Not one galaxy at different angles, but a million galaxies all scattered in random angles. And
Right.
so it's pretty easy to figure out what we look like by looking at others,
others.
Yeah.
adding,
And-
Yeah,
Right.
and that's what we look like until we collide with Andromeda. But one of the things I took solace in, but I feel like Neil's about to
No,
make me
I
very
have to- I'm
uncomfortable.
sorry.
But the whole solar system's supposed to stay together, right, and get knocked around.
We should stay together.
So we might end up in Andromeda. Before we fully collide. Like they could pass each other. They could collide, move through each other, and we could end up in Andromeda looking at the Milky Way.
And Milky Way, we're going to leave it forward in an address.
So what'll happen is there'll be a lot of sort of dissipated energy, and the system will of course pass through each other and back and forth. We've done this on a computer, and it's like a rubber band kind of thing, and it kind of dies down and it settles into one double large massive system.
Okay, so what's the bad news?
Okay, so I hate to break the news.
That sounds like good news to me.
Okay.
Yeah.
So if Andromeda were 100 times closer, it wouldn't be any brighter on the sky.
Interesting.
Yeah,
Okay, I'm live. You've lost me. You totally lost me.
I'll tell you why. Okay.
Yeah, tell me why, 'cause it's not obvious.
Okay, I'm going to tell you.
Yeah.
I'm going to tell you.
Okay.
Can I tell you? Okay. All right. So Andromeda has a certain size on the sky. correct?
Right.
Okay, it has a certain extent. And on a very dark night, not in the city, but where the moon is not out, you can see this fuzzy thing in the sky. So that's in the Andromeda Galaxy. It's 2 million light years away. All right. There's a certain amount of light coming from Andromeda in that patch on the sky.
Right.
So we reference its something called a surface brightness. It is how bright is Andromeda over that patch of sky, over that surface patch on the sky. Surface brightness. Okay? If we bring it half as far away, okay, make it only half as far, it is how many times brighter?
It should go like the square.
Like the square.
But then the area
it'll be
is also
4 times brighter.
But the area doesn't go like a square.
By a factor of 4.
Yeah.
So the whole system is getting brighter, but the surface area is remaining the same.
Right.
So it is not going to be more apparent to you in the night sky than our own Milky Way is on our own night sky. I'm very sad to report that. I'm just sad.
But it'll look cool.
It'll look cool.
No, it'll just still be fuzzy. Can I see it? You got to get out of the city, get rid of the full moon. Now I see the colliding galaxy.
Right.
No, I'm sorry. I'm very sorry about this.
Okay.
Janna, I'm sorry to report this.
That's right. I'm,
It'll just look like our own Milky Way galaxy.
Yeah.
If Andromeda were right here next to us, it would just look like our Milky Way in the night sky, which you cannot see from New York
Which
City.
you cannot see from New York City.
Okay.
It is too. But you can see with one of those apps, like you can just, you can hold it. It could
Hold
be
your
like
smartphone.
Hold up your
you
smartphone.
have to hold it, and it could be like down there, and it'll show you like a beautiful.
Show you Andromeda on its way, and you pump up the intensity.
Who needs eyes? Overrated.
It's true. We're practically blind.
This is the new model for astronomy.
Yeah.
Who needs eyes?
We're becoming cyborgish.
She is so right on this. Chuck, we
cool glasses.
As the centuries went on, we discovered how blind we actually were.
Yeah, that's amazing.
Yeah.
All right, there we go. Okay, let's move on to David.
Oh, by the way,
go ahead.
those Hubble photos?
Yes.
If you go to those objects, you don't see what the Hubble saw because the Hubble sees better than you do.
A lot better.
A lot better.
Yeah.
I mean, if you could just like stare at it for 10 days.
Or if your eyeballs were like
gargantuan,
then it'll look like what the Hubble sees.
Right.
Yeah.
All right.
Cool. All right. This is David Eduardo Perales Martinez, who wants to know.
You did good there.
Yeah, well, not bad. My wife. My wife is Puerto Rican.
So you get a little bit of, let me hear that again. Go.
David, or would be David Eduardo Perales Martinez.
Martinez.
Yes. Who says this? Why is it so hard to prove the existence of other dimensions? Thank you. David from Mexico. Or Mexico.
I want to ask that a slightly different way.
Yeah.
Go ahead.
If there was another dimension as big as the 3 that we're in, would it completely manifest to us?
Probably. There's a hitch. So you would think, yes, as long as that dimension was very large, then we would be talking about a world in which this did not confine us, right? So let's say I have skin, which seems to separate my inside and my outside. But if there was another,
see right inside you.
If there was another dimension, you could do like one of those spooky surgeries without puncturing any skin. You could just like go in there and touch people's organs. Like this would not be a separation of inside and outside.
Well, there's also an analogy to that is if you only live in 2 dimensions, then you only have sort of height and width, you have height and width, but not depth. Right. So if you don't have depth, if I look at you in 2 dimensions, I can see all your organs.
And for you,
I just reach in and pull out your spleen or whatever. You can't see because you're in and all you see is the outer skin, which is just a line. Yeah, and now our outer skin is a surface.
Right. So which is why you can't actually probably have a very effective organism in just 2 dimensions because let's say they had a mouth and a tube going all the way through them, it would actually cut the 2 sides in half.
Yeah.
So you can't have what we consider to be normal metabolic functions of. Okay. Anyway.
You know what else you don't have? You don't have porosity in 2 dimensions.
Yeah.
Okay,
You
tell
can't
me
have
what porosity is.
So if you drop water on soil and then it just soaks in.
Right.
Or you drop it on a sponge and it soaks in.
Okay.
In 2 dimensions, there's no such thing as.
There's no soaking.
There's no
soaking in. Right. So you just have a bulb of water.
Correct.
Sitting on top of it.
Because porosity enables, you have let's say 2 rocks are touching here. But then the water can just go around another side of the rock.
Right.
But in 2 dimensions where they touch, there is no way past it.
Right.
It'll just stay above it.
Is that where you're able to smell what the rock is cooking? Okay.
No,
we're like.
That was, don't worry.
So here I will tell you this: that some people argue that the reason why the universe is 3-dimensional is because the universe tries to be many different ways. Like, there may have been an infinite number of big bangs in the past and the future. Can't really talk about it in temporal relativeness, but if the universe created a 2-dimensionally large universe with all the rest rolled up and small, you couldn't have organisms in that universe to ask the questions.
Wow.
So you'd need at least 3. And then let's say you had 4 spatial dimensions. Then you have the problem of things drift away from each other in such a way that it's hard to have organized systems. So just like Neil was describing, a 2-dimensional creature isn't aware of the 3rd dimension, but if they became aware, they could just kind of float away from their city, right? It becomes, you have more volume of space to fill. The cross section for interaction goes down. So now if you add another dimension, dimension, the cross-section for interaction goes down again. So
No, but we successfully exist in 3 dimensions in spite of the challenges the 2-dimensional creature would face upon accessing a 3rd dimension.
Right.
So why
maybe 3 is optimal?
Why don't 4-dimensional creatures pity us?
Yeah. Right. Well, that is a good question. Could the complexity, I'm not saying they're true arguments, but some people argue that you couldn't in the 4 dimensions get the successful complexity. And some of those arguments they get, complicated based on string theory, cross sections and annihilations into photons and what's left over after all of these things in the Big Bang. It turns out that only a tiny, tiny bit of stable matter is left over already in 3 dimensions from the Big Bang.
So it could be. Wait a minute. Let me kind of agree with what you just said, even though I just disagreed. What you're saying is, in 3 dimensions, it could be optimal for particles to get together and make molecules, and molecules to make macroscopic objects. If you add a 4th dimension, you're adding a degree of freedom of where things can hang out and possibly never then find each other.
Yeah,
ever
it could
again.
If you think about the volume of the universe is going up radically with the volume of dimensions,
yes,
then you're diluting everything in the universe.
Concentration of what could be. Ooh.
But there's any
so the fact that you're even asking that question means you are a being in an optimized universe to even pose the question in the first place.
So the 2-dimensional people couldn't ask this question?
Right, because they couldn't be 2-dimensional people, because the structures are too simple to allow.
And 4-dimensional people, there's too much play space.
So let's take your first question was, would we know it if the other dimensions were large? Here's the hitch. You would think we would, but here's the hitch. Even if all of those problems were solvable, there's an argument that we could be glued to a kind of a membrane, which is a 3-dimensional surface floating in this higher dimensional space. And we're
so
glued to
there?
it. It's the Elmers. The way the fundamental forces work between,
they keep us there.
They keep us on the membrane. And the only thing that happily goes off the membrane is gravity itself.
Right. Oh, man.
So that all other forces are glued to this membrane. That's where they live. So that you would think like a particle to you interacting with that membrane could be a string in the higher dimensional space.
Passing through your space, manifesting as a particle.
Manifesting as a particle. So like imagine cutting a string, it would look to you like a dot.
Right.
An infinitely thin string. So
that is wild.
The way I think about in 2 dimensions, I think of passing a hollow sphere through 2 dimensions. What would that look like to the 2-dimensional people? They'd see a dot. They say, "Oh, that's cool." Right. Oh, then it becomes like a circle. And it gets bigger and bigger and bigger. Then it maximizes out at the diameter, but they don't know this. And then it gets smaller, then it gets a point and disappears. And
they have no idea.
They have no idea.
A big sphere
and all kinds of mystical, magical hypotheses come out.
Yeah.
And the scientists analyze it.
Yeah.
And we just say stuff pops in and out of existence. We don't know why.
So absolutely. So one of the things that we've worked on with extra dimensions that make them not just an oddity, but maybe something we've already observed.
One of the things we've worked on our extra dimensions. Jen, what's in your basement? She's a superhero nemesis character in the making.
My superhero character name is Jan 11.
Oh.
Isn't it good? And it's a prime number.
Jan.
I mean, I've got to work that somehow.
No. You don't want to be super. You want to be the nemesis.
Oh,
that's way more fun.
It is
you can
way
be diabolical
more fun.
with the science.
That's Jan 12.
My evil twin, Jan 12.
Jan 12.
So the interesting thing there that people have thought about is that maybe something like dark energy is actually a quantum phenomenon trapped in the extra dimensions, that we can't perceive the extra dimensions directly, but we're indirectly perceiving them through the dark energy.
Or dark matter is regular matter in the higher dimensions leaking over
into
and
through this membrane.
And we're just doing this, and it's just mysteriously there.
Yeah, people have definitely wondered if dark matter can have to do with
the thing that is the medium. Is that the deal?
Gravity is space-time, so gravity can't be confined
to.
Otherwise, that would be no meaning to the extra dimension.
Stupid.
Everybody knows that, Chuck. Spell your problem.
So we got to take a quick break.
Okay.
When we come back, more with Janna Levin on the edge of the universe and beyond when StarTalk returns. We're back. StarTalk, Cosmic Queries, the edge of the universe. There's only one person in arm's reach out there who could do this. Janna Levin. Janna. She's our go-to person.
Yes.
I love being the go-to person. It's the best.
Totally the best.
I have actually written papers on extra dimensions. It is a genuine direction in my research is to think about
So when she disappears,
we'll know. Wouldn't that just be so cool?
Yeah.
You just got up and then went into the 4th dimension. And then might just disappear.
This is how Monsters, Inc. worked.
Yeah.
Monsters, Inc. These are doors that came out of the factory.
Right.
This was an uncelebrated fact of that movie. These are 4-dimensional portals. They're basically wormholes.
They're amazing.
Each door, this is the door to the kid's room. And the monster takes it home at the end of the day, and they open the door, and on the other side of the door is the kid's closet.
Right.
Okay?
So great.
And then they come out of the closet, scare the kid, go back through the door, and they're back at home.
It is a great movie.
Yeah.
Great. Okay.
I love it. All right. Let's go to, well, you know what? Let's go back to a Patreon patron. This is, Solarcero de Rai, okay, who says, what do y'all think about the, you like that?
That was good.
What do y'all think about the idea that matter consumed by black holes has been recycled and manifested back into the universe as dark energy?
So matter coming out the other side, maybe.
Right.
Okay.
So is there any correlation between the matter consumed by black holes and dark energy? Could black holes and dark energy, dark matter be different sides of the same coin? So,
Give it to me.
yeah.
Well,